students, in our chapter Stars and the Solar System. Let's look at the new topic that is satellite. See, students, just as a celestial body which revolves around the sun is called a planet, in the same way, a celestial body which revolves around a planet is called a satellite. So, satellite is a celestial body that revolves around a planet, and Earth is a planet. Now, since the moon revolves around Earth, this is moon, and moon revolves around the Earth, so therefore, moon is a satellite of the Earth. S- And one more thing that moon is the natural satellite of the Earth. As we will learn after a while, that many artificial satellites, many man made satellites are also revolving around the Earth these days, but Moon is the natural satellite of the Earth. And so satellites revolve around the planets, Moon revolves around the planet Earth due to the gravitational pull of the planet Earth. That means it's Earth, gravitational pull of Earth, because of which Moon revolves around the Earth. So the satellites revolve around the planets due to the gravitational pull of the planets. And one more thing, satellites have no light of their own. They shine, they become visible to us because they reflect the light of sun that's falling on them. Okay? So let's describe the Earth's natural satellite called Moon. Okay? So Moon is the natural satellite of the Earth. Moon revolves around the Earth on a definite regular path. That means on Moon's orbit. Okay, so Moon revolves around the Earth in a fixed orbit, as you can see here in this diagram. Okay, this is the Moon's orbit, and the Moon is revolving around Earth. And gravitational attraction of Earth holds the Moon in its orbit. Okay, so basically, Earth along with Moon, they both are actually revolving around the sun. Okay, so and one more thing, Moon also rotates on its axis like Earth is rotating. Okay, Moon, the Moon completes its one revolution in 27.3 days, and in Hindi calendar, this 27.3 days, this time is taken as a month. Okay, Moon is the closest celestial object to Earth, as the distance of Moon from Earth is just 384,000 kilometers. So it is the closest celestial object to Earth. Okay, and one more thing, Moon appears to be much bigger than the stars, right? Because it is much more nearer to Earth than stars. In fact, all the planets and stars are much bigger than Moon. But Moon is close to us, that is why it appears bigger than the planets, than the stars. Okay? And the diameter of Moon is the 1/4 times diameter of Earth. That means it Moon is about 1/4 of the size of Earth. Okay? And the mass of Moon is about 1/18th of that of Earth. Okay. Now, if you look at this picture, this is the picture of Moon. This is the surface of Moon. So basically, Moon is a huge ball of rocks. Moon's surface is covered with hard and loose dirt. There are many craters of different sizes on the surface of Moon. You can see here, these are the craters on the surface of Moon. Craters are like depressions. Okay, so these are the depressions on the surface of Moon. So the surface of Moon has a large number of steep and high mountains. It's covered with hard and loose dirt, craters, and mountains. And Moon has no air, no atmosphere. In fact, moon has no water. So since there is no air, no water on the moon, so no life is possible on the moon. Okay, and we cannot talk on moon, as you know that sound needs a medium to travel, and on moon there is no medium, there's no atmosphere which makes the sound to propagate. That is why we cannot talk on moon. Okay, and on the moon days are extremely hot and nights are extremely cold. And man has landed on the moon. The first man to land on moon was an American astronaut, Neil Armstrong. He landed on moon in July 1969. And then he was followed by another astronaut, Edwin Aldrin. Shortly afterwards, he was followed. Okay. Now, see, students, you all see the sun, right? And sun is seen because of its own light, right? But moon does not produce its own light. Even then, we are able to see it shining in the night sky, right? So we are able to see the moon because the sunlight that is falling on the um, moon gets reflected towards the earth. And when sunlight falls on moon, then a part of the sunlight is reflected by the surface of moon towards earth. As you can see here in this picture, this is the sunlight falling on the moon, and part of sunlight is reflected towards the earth. And when this reflected sunlight enter our eyes on earth, um, to us it appears as if light is coming from moon itself. And since the sunlight reflected by moon enters our eyes, we are able to see the moon. So moon shines with the sunlight that's reflected by it. But yeah, students, we can see only that part of moon from which sunlight is reflected towards us on the earth. Um, Note this point that though the moon reflects sunlight towards us even during the daytime, but we cannot see the moon during daytime because of the glare of the sun, as we have discussed it earlier. And we can see the moon only during nighttime when the sun is not present. Okay. Yes, students, observe these two motions here. Both are revolutions. If you can see that here these trolleys are moving, revolving, right, around this fixed yellow point. And here again, these trolleys are moving around this fixed point, right? So in both pictures, there is a revolution happening. Now let's look at what is the difference between these two revolutions. See, students, suppose look at this trolley. If you look at this trolley, you can and suppose ride takes place and this trolley starts moving, revolving. See, students, here someone is sitting here at this yellow point, okay, and he's looking at this trolley and he's looking the front part of the trolley, right? Now when this trolley moves here and the person looking here, when he sees at this trolley, he sees this trolley, he will see the bottom part of the trolley, right? And when this trolley reaches here at this point, the person will see the back part of the trolley. And when this trolley reaches here at this point, the person sitting here at this yellow point will see top part of the trolley. So that means while revolving, the person in the middle or someone which is looking at can see all parts of this trolley, right? Now look at this revolution. Say for instance, let's take this trolley. A ride has taken place and a person is sitting here at this yellow point and he's looking at this trolley. He's seeing this part, this bluish part of the trolley. Now when this trolley moves and reaches here, the person will again see this part of the trolley, right? When the same trolley reaches here, the person will again see this part of the trolley. That means during this revolution, the person sitting in the middle or someone is able to see only the one part of the trolley, right? He's not able to see the other part. What's happening in the other side, he's not able to see. So, these are two different kinds of revolutions. So, students, what about the moon? How is moon doing its revolution? So let me tell you, students, this revolution does not take place in moon. Moon revolves like this. That means moon revolves like this, and we are able to see only the one part of the moon, one half of the moon, because at every time only one part of the moon is visible to us, and the other half is always hidden from the earth. So means one part of the moon is reflecting light towards us, and we are able to see only one part of the moon, one half of the moon. The other half of the moon is always hidden from the earth. So moon revolves like this. That means only one part is um, we are able to see only one part of the moon. Hope you have understood this.